So Algebra 2 students, let's do the homework. We're using square roots to solve quadratic equations this unit. For standard form, ax squared plus bx plus c. We do this method called completing the square, and the method kind of creates this formula. It's called the quadratic formula. The quadratic formula uses a square root to solve these quadratic equations. Okay. All we have to do is use the formula correctly. We see the plus or minus. Remember, when we're using square roots to solve equations, we need a plus or minus. There it is. It's right there. See how there's two different forms. It's either like one big numerator divided by 2a or two different kind of parts, both divided by 2a, where we have the axis of symmetry, which is the middle of your quadratic. I like this form because you can kind of see this has got to be a middle plus or minus this like distance to solutions. Like you got your middle. Well, since it's symmetrical, if one solution's this far, the other solution is going to be the same distance on the other side. Okay. All we got to do, identify A. A is the number that comes before x squared. B. B is the number that comes before x. C. C is the number by itself. Plug those numbers into our quadratic formula. Okay. I'm going to flip-flop which method I use. Do the method on the left for this one, do the other method on the right for that one. Now, we actually know how to solve this already by factoring. So I'm going to actually check at the end of this problem if I get the same answers by factoring. Okay, so here's what I do. I got x equals negative b. Now, that's the opposite of b. If b is negative, you make it positive. So negative b over 2 times a. Now, if you want to, you can just turn that into 3 right away. Be careful. I'd probably do like 2 times a on the side before dividing the 2, or I'd use my fraction button because a big mistake occurs when we say a is like 2. We do this and then multiply by something else. Like this needs to be in parentheses. So just take your time and be careful. Okay. A lot of this is just calculator careful stuff. All right. Plus or minus square root b squared, use parentheses, minus 4ac all over 2a. I like to work inside my square root. So I'm just going to work in the top here. And it's up to you, like how you want to do this. One step at a time, doing it all at the same time. You can work on b squared first. I'd probably use parentheses just to be careful. B squared. And then 4ac. Do that second. And then subtract the two numbers. You can do that. Or you can literally work, and again, don't worry about the square root yet. Just do it all at once. As long as you're using parentheses, you're going to be fine. But don't do the square root yet. It'll work out sometimes, but other times it's not going to be nice. Okay, so I get the square root of 4 on the inside. This is divided by 2. Okay. Now I'm going to keep simplifying. The square root of 4 is actually a number. The square root of 4 is 2. So this is 2 divided by 2, which is just 1. So this turns into the square root of 4 over 2, which turns into the 2 over 2, which turns into 1. So we have our solutions 3 plus or minus 1. Okay, and again, you don't have to show all this work. I'm just kind of showing you like either you can go to the right to simplify this, or you go down. It's probably better to simplify down, so I'll just show that. That way you keep everything. We got that plus or minus, it stays. We got that 3, that stays. Got this x equals. Okay, now two solutions, 3 plus 1 and 3 minus 1. 3 plus 1 is 4. 3 minus 1 is 2. Sorry. Negative b over 2a. Negative 3, negative 3, negative 3, negative 3, negative 3. My solutions are negative 2 and negative 4. Sometimes the formula gets you, you got to pay attention to all that. Like the opposite of b. B is positive, so it becomes negative. I was just like talking ahead for when b is negative. All right, so those are my solutions. X equals negative 2 and x equals negative 4. Now, if you remember, a is 1. We can factor this. Two numbers that multiply to get a times c and add to get b are 4 and 2, which means x squared plus 6x plus 8 can look like x plus 4, x plus 2. We can double check that. X plus 4, x plus 2 is x squared, 4x, 2x, and 8. That's 6x. Okay. We get x equals negative 2 and negative 4. Those are the values that'll make the pieces 0. So there you go. Like we've been able to solve that before by factoring. But it's the ones that we can't solve by factoring. Like, are there two numbers that multiply to get negative 2 and add to get 8? Are there two numbers to multiply to get negative 2 and add to get 8? I mean, there are. But you don't say no solutions, actually. It's your solutions are going to be potentially decimals. The only way for us to like really say that I have no solutions is either by graphing and seeing there's no real solutions, or by using the quadratic formula and discovering that you can't use it because you can't like have a negative in a square root. This always happens with Desmos. Desmos is like too much for Google Chrome to handle. Look at my face there. That's a hilarious face. And Spain scored again. Oh, there you go. Look, just because I can't factor this doesn't mean no solutions. Okay? So like on your test, we had a question where it's like not factorable, no solutions. It's like, it was, but like the only way you actually know that there's no solutions is if you use the quadratic formula to double check. Because sometimes things can't be factored, but you can use a square root to solve by using the quadratic formula. Okay, let me use the other technique. Okay, a is the number that comes before x squared, b is the number that comes before x, c is the number here. Let's use the quadratic formula, but the one on the right. So we get x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Well, again, like let's just kind of work at this one piece at a time. Negative 8 stays negative 8, 2 stays as 2. Let's work inside the square root. You can go one piece at a time. I like to do the whole b squared minus 4ac all at once. And I get 72. Okay, now try to take the square root of 72. Hopefully that works. It does not. Now this is the time where we have to simplify. Simplifying is when we try to take big perfect squares and rewrite our square root as a simplified like root times another root. So some perfect squares to remember, slash to know, slash will be given to you are these: 49, 36, 64, 25, 16, 9, 4. Let's try to find the biggest one of these that goes into that, 72. So like I try 36. Oh, bingo. If I tried 49, it wouldn't work. All right, now that means 36 times 2 is 72. But since this is root 72, I'm going to come up here. We will write it as root 36 root 2. Okay? The reason why we do this is we can turn the square root of 36 into 6. You can use your calculator to do that. Now, typically with the quadratic formula, they don't like the answers like this. They like two separate answers. So they actually want you to simplify anyways, which is why I like the form on the left, because it actually does the simplification like along with it. You get both of these pieces can be divided by 2, which means the 8 divided by 2 turns into -4, and the 6 divided by 2 turns into 3. Now, these two numbers, -4 plus 3 root 2 and -4 minus 3 root 2, are ugly numbers. You're not going to be able to do those in your calculator. You could try, but you can't simplify. It's not whole numbers. Turns out, we'll be able to see, -4 plus 3 root 2. I'll just do 1. Is 0.242. Okay, 0.242. Now let's go and look. Look, 0.242. To be exact, it was 0.2426. So your Desmos simplifies it to 0.243. We found that exact number. Now, our number is exact. This number is an approximation. They only gave you 3 decimal places. So our number is better because it's exact. Now, we don't want you to put the decimal. We don't want you to put this a whole thing, and we don't want you to round it because that's not exact. So what we ask you to do is write out the two solutions, -4 plus 3 root 2 and -4 minus 3 root 2. And those are your solutions. Okay, so this is all doing it at once. Really, like the difference between the two forms is like this one simplifies kind of as you go and at the end, and this one we just simplify at the end, and we get the same answer. All right, so again, we're solving these square roots using we're solving these quadratic equations using a square root. Because we're using a square root, we need the plus or minus. And smart mathematicians discovered, there's a formula we can always use. Okay. We look at number 3, and here's a big mistake made. We see this quadratic. People say 1, 2, and 4. Wrong. Guys, just like in last unit, we need to get everything onto one side. Always, always, always. The quadratic formula does not work unless everything's on to one side. How do we do that? Well, it's not magic. It's algebra. You move, subtract, get rid of the stuff on the right side, subtract to remove it, or add the opposite, like whatever you want to do so that you get a quadratic equations equal to 0. Quadratic equation equal to 0. This is what we want. We need to have this. To recognize that A is 1, B is -2, C is -4. Okay? Again, like if you tried to factor this, two numbers that multiply to get -4 and add to get -2, they don't exist. That doesn't mean there's no solutions. This is the quadratic formula is the way to check to see if we have no solutions or not. You could graph the check. If you ended up with the square root of a negative, you'd say, yeah, there's no real solutions, but we'll talk about how there's more to that next lesson. Okay, so just use our formula. I'm going to go back to the one on the left. I got -b. Now let's pay attention. Like -b would be -2. You really like to say it's the opposite of b. The opposite of b. So if it's -b, but b is negative, that becomes a +2. Over 2a, that turns into a nice 1. So the left side's taken care of. I got plus or minus square root. Use parentheses because your calculator might tell you -2 squared is -4. That's wrong. -2 times -2 is +4. B squared minus 4 times A times C all over 2 times A. That's just 2. Let's work inside our parentheses first. However you'd like to do this, just don't use the square root until the end. I like to do it all at once. Five. Oh, yo, this is like a touchpad. I bet you I could do this with my fingers. Yeah. Let's see. B squared. Oh my gosh, this is so much easier. It's so silly. I should have known this earlier that this laptop is a touchscreen. All right, anyways. Underneath the square root is a 20. Okay, 20. But the 2 is still there. Now, can we square root 20? No. Can we take one of those perfect squares and divide it by a number? Like, can 20 be divided by 9? Can 20 be divided by 4? Yes. That means 4 times 5 is 20, which means root 4 times root 5 is root 20. Root 4 is 2. 2 divided by 2 is 1. 1 root 5 is the same as root 5. These are my solutions. They're ugly decimals, but just because we couldn't factor that doesn't mean there's no solutions. There actually are 2. 1 plus root 5 and 1 minus root 5. We can check using Desmos really quick, just for fun. Okay, I got negative 1.236 and 3.236. I'm just going to do it here. 1 minus squirt 5, negative 1.236. 1 plus squirt 5. 3.236. We are finding the locations of the x-intercepts using square roots, using the quadratic formula. Okay, same deal here. Move everything onto one side before we identify A, B, and C. Okay, A is 2, B is negative 4. Careful, B is negative, C is negative 3. I'm going to use the one on the right, the one that most teachers teach. X equals the opposite of B. Negative B is negative negative 4, which is positive 4. Plus or minus the square root of B squared, use parentheses, minus 4AC, all over to A. Great. The bottom can be simplified to be 4. Let's get our calculator out. Using parentheses, negative 4 squared. Oh, it's not exact. Minus 4 times 1, it's still faster, times negative 3. My camera's shaking though. 28, square root of 28. I've done the stuff inside the square root. Is the square root of 28 a nice number? No. Can I simplify 28 by pulling out a big perfect square? 16? No. 9? Again, we're using those big perfect squares that we've used before. Nope. 4. Yep. 4 and 7. So 4 times 7 is root 28. So 4 times 7 is 28. So root 4 and root 7 multiplied is root 28. The reason why we turn that into root 4 root 7, because the square root of 4 is 2. That's a number. Don't say it's root 2. The square root of 4 is 2. So 4 plus or minus 2 root 7 over 4. Now we simplify. We kind of divide both of these by 4. So I got 4 divided by 4, which is 1. And then I have 2 divided by 4. Don't do 4 divided by 2. 2 divided by 4 is 0.5. 0.5 is a half. So, maybe like this, like doing this and at the end dividing, it works out either way. It's really totally fine. The only reason why I like the one on the left is because I like to see where negative b over 2a comes from. Where does the vertex come from? When we graph, you could also write this as root 7 over 2. It's up to you. Whoops. Okay. Do you want to see it in action? I do. I just love to see like answers and like I love to see that I did everything right, and I love to see that without having to like I don't know use like a computer program or something. Like it's like oh did I solve this correctly? Rather, it's like I can see my answers. Okay, negative 0.823 and 1.823. I have 1 minus root 7 over 2. Negative point. Oh, was it right? See, this is when it's like, oh, I'm a little bit worried here. 2x squared minus 4x. So something happened. Something happened. $16 minus 24. That's bigger. I messed up here. Yeah, there it is. Glad I checked. It's hip surgery messed me up. B squared minus 4AC. Should be that. 40. Well, at least I know my mistakes. And at least I can fix it. We've seen root 40 before. 40 can be divided by 4, and it's 4 times 10. So this turns into 10. It's really not that much of a change. But still, it's like, come on, Mr. Messer. This is like good to show, like, teachers make mistakes too. It's good. It's good to see that it happens, but watch me fix my mistakes without having to like look at a key or anything. It's gonna be root 10 times a half, or root 10 over 2, and then I'll be able to see those correct answers. All right, back to Desmos. Change that to 10. Change that to 10. Negative 0.581, 2.581. There you go. Okay, those are my solutions. They're decimals, but that's okay. All right, 4 more. Let's kind of blow through these. We got 9, 12, and 4. Opposite of b over 2a. Ooh. Plus minus square root. B squared minus 4 times a times c. All over 2a. I mean, let's work on the left side here. 2 times, like, here's the example of, don't do that. Wrong. Okay? You either do negative 12 divided by, and in parentheses, 2 times 9, or use your fraction button. I messed up. Okay, negative 2/3, or use your fraction button. Let's go into alpha F1. Type in negative 12 over 2 times 9. They ensure that things are in parentheses or 2 parentheses 9. And that automatically gives you the answer here. So we got negative 2/3 and then plus or minus. Let's work inside the square root. Positive 12 squared minus 4 times A times C, making sure I'm using the correct numbers. 0. Oops. Yo, what's the square root of 0? 0, because 0 times 0 is 0. Oh, okay. Guess what's going on here? We have one solution. Negative 2/3 plus 0 and negative 2/3 minus 0 is really the same number. We're not going to write it out twice. A lot of you did this when we factored. But this is a situation, and we can see it when we have one x-intercept. Is at the vertex. All right. Next one. ABC 342. Use the other formula, the one where we simplify at the end. Negative b. I don't care. Honestly, I'm not going to judge you if you use one way or the other. Negative b plus or minus b squared minus 4 times a times c all over 2 times a. Just kind of work one step at a time. I'm going to do the bottom. 2 times a is 6. I'm going to do what's in the square root. Breaking out my calculator. 4 squared, no negatives, so that's nice. Minus 4, come on. 4 times 3 times 2. And I get negative 8. Okay, I tried to take the square root of negative 8. Uh-oh. Non-real answer? You know what that means? There are no real solutions. But that's the key statement. No real solutions. You can't take the square root of a negative. This is kind of the way that the quadratic formula shows you, oh, this is when we know we don't have any real solutions. It's not that we can't factor. It's if you have a square root of a negative, there are no real solutions. Don't worry. We are going to talk about having imaginary solutions and how we are not going to stop in the future. Next class, we're going to actually keep going from the square root of negative 8. Here, if this was 3x squared plus 4x plus 2, we saw, oh, you're above the x-axis. There's no x-intercepts, no real solutions. Turns out we got imaginary solutions. 5-0 Spain. Oof, they're tough, man. I'm throwing this one. I think this one was in your notes. It's in your notes, or it should have been in your notes. I don't know if I fixed it. Everything's on one side. We're good. A, B, C. Go back to the left side. Opposite of B over 2 times A, plus or minus square root B squared minus 4AC, all over 2A. Use your calculator. Use your brain. Negative 2 over 2 is negative 1. Let's figure out what's inside the square root. Use your calculator. 2 squared minus 4 times 1 times negative 1. This is so much faster. 8. Oh. No, I guess two numbers that multiply to get negative 1 would have to be positive 1 and negative 1. Which doesn't add to get 2. So this is a good one that has Some crazy decimal solutions. Next thing, can we take the square root of 8? Nope. Can't take the square root of 8. Can I divide 8 by a perfect square? Yep. 4 times 2 is 8. So root 4 times root 2 is root 8. We do that because the square root of 4 is 2. Two divided by 2 is 1. Maybe you don't like doing this. Maybe you like doing the other way and dividing at the end. I'm okay with that. It's fine. Negative 1 plus root 2, negative 1 minus root 2. Let's see our handiwork. X squared plus 2x minus 1. Negative 1, negative 1 plus root 2 and negative 1 minus root 2. 0.414. Bam. Bam. Negative 2.414. Bam. Okay. And last one. A is negative. All right. Whatever. Whatever. Now, guys, what the quadratic formula would tell you to do is divide everything by negative 1. Make A positive. The quadratic formula would tell you, use positive x squared positive 8x and negative 2. You're going to get the same answers as using this. Most students don't do this. Most students are just like, A is negative 1. All right, it's fine. Let's do that. B is negative 8, C is 2. X equals negative B. Negative B, the opposite of B, positive 8, plus or minus the square root. B squared minus 4AC all over 2A. Simplify the bottom. It's honestly, it's fine doing this. Let's get the inside of the square root. Using parentheses when we square things. $72. We saw 72 earlier. 72 is 36 times 2. Can't take the square root of 72. Can you divide it by a perfect square? Yes. 36. 36 times 2 is 72. Root 36 times root 2 is root 72. Six root 2 is what root 36 root 2 simplifies to be. Finish off by dividing by negative 2. I mean, I like this method too. This is totally fine. Divide this and this at the end by negative 2. And we get these two. Negative 4 plus or minus 3 root 2, which means you're going to get negative 4 plus 3 root 2 and negative 4 minus 3 root 2. Okay, let's see our handiwork. Wish I did this in the notes, but whatever. You guys just care about the homework anyways, right? So the notes video, I like having this up. Three root 2. Negative 4 minus 3 root 2, negative 4 plus 3 root 2. There's my equation, 0.242 right there. Bam. Negative 8.242 right there. Boom. Okay. All right, so that's the quadratic formula. roots, how we use square roots to solve standard forms. We know how to use square roots to solve vertex form. We know how to solve square roots for vertex form, for like difference of squares form. Now this is the final form. Intercept form, we know how we don't need square roots. So it's like we've covered every single type of form of a quadratic equation and how to find the zeros. It's fun stuff. Math is fun. All right. Hope you are ready for next lesson where we talk about imaginary solutions. Peace.